Welcome. We are going to look at rational expressions and multiplying and dividing them. Rational expressions are simply fractions where you have variables on top and bottom, and of course other stuff with them. And we're going to be doing multiplying and dividing with them here. First, we need to review some of the techniques for factoring. And the first one is taking out a common factor from something. Both of these terms have 2 in it and an x in it. We end up taking those out. In a difference of 2 squares, you need to have the formula memorized that if you see a difference and 2 things are perfect squares, sort of like this is, 49x squared is actually 7x times 7x, and 36y squared is 6y times 6y, then you do them both like this where one is plus and one is minus. You're going to see these in some of the problems we do, so you need to remember to notice them and then use them when it comes up. And for a difference to cubes, there's a specific formula to use. And you just have to pay attention to the signs. It's the same formula whether it's the adding or subtracting. So 27x cubed is actually 3 cubed and x cubed, and we show it this way. And 125y cubed, well, that's 5 cubed, and a y cubed, so it's 5 and y. So the 3x plus 5y goes together because this is plus. And then you have the 3x being squared, like that shows. And here you have the 3x times the 5y, like this shows, so it's both of them. And here you have the 5y being squared. And in between, notice that if this is a plus, then, well, actually, let's go. If this one's a plus here, then it's a, well, you have to watch which one because it really depends. So let's actually emphasize what it is. If it's a plus, then it's plus and minus there. If it's a minus, then this is a minus and that's a plus. These switch. So in this case, if that one's a plus, then that one has to be minus. Or it would have been the other way around if it was subtracting. When you do a trinomial factoring like this is where you think what 2 numbers multiply to 10 and add to 7. So it's a 5 and a 2. Multiply and add. So there's a 1 here. It's supposed to be a times c. And so this is actually a times c. When you do it with a trinomial factoring, well, first for 5x squared, there's no choice. We're going to have an x and a 5x. But for the in-between ones now, we have to do 5 times 6, that's 30, that's a times c. And 17 is the b, so we have to add up to 17. And the 2 numbers that would make that are 15 and 2. They would add to 17, multiply to 30. So in this case, we would do 5x, we would put 5x twice. This is one of the ways to do it, at least. And then I'll put the plus 15 and the plus 2. And in this one, we can take out a common factor of 5. X plus 3, and then 5x plus 2 for that one. And this is the only time that you throw away something like that, only because you have written it twice and you only read it once. So you have to be able to factor trinomial sometimes in these problems. And then the grouping method is where you group the first 2 and then the second 2, and you take out the common factors. And as long as this is the same, you can then take that out as a common factor and put the x squared minus 2. Ooh, if that had been x squared minus 1, I would have factored it again as a difference of 2 squares. Now we're going to use those different factoring techniques in these problems. So let's start off here looking at this first one. We have to divide this. So let's take out a common factor first. I see all the top ones have 5s and 2 extra x's. So 5x squared would be a common factor for that. And that would leave us 3x squared plus x minus 4. And on the bottom, each of these 2 can take a 5 and an x out of them. So I would have a 3x plus 4. That means that the 5s can cancel and one of these x's can cancel. So now what I have is an x on top plus 3x squared plus x minus 4 can be factored. That's a 3x minus 4 and an x minus 1. When there's 3x minus 4 plus 4. That's going to be plus 4 and minus 1 here. Okay, because then I get 3x plus 4. Yep, it's 3x plus 4. And on the bottom, oh, there's a 3x plus 4 on the bottom. And that means that this and this can cancel. So our actual answer to this is x times x minus 1. So that's the simplified, broken apart part as much as possible. Okay, let's try to get all that staying together. It would be okay to write this as x squared minus x, but not really, because it's not broken down all the way to common factors. So please do it that way. On the next problem, let's start taking out common factors and see what's there. Because on the top of it, I can see I can take out a 3. And once I take out a 3, now I have something that I can work with because they're 2 cubes. Right now, the 24 is not a cubic. It's not something to the third power. Neither is 3. But once I take out the 3, now I see that I can actually have this as 2 times x to the third, because 2 times 2 times 2, minus y to the third. So that's what I have there now. So I'm actually going to make that, well, no, I am not ready to do that there. Let's take this apart. And I'll write that here this way as 2x to the third minus y to the third. Now, underneath it, when I look at all this, all I can do is really just take a 3 out of it. Okay, so I have 4x squared plus 2xy. That's for this part here. Divide by 3, and then plus y squared. Okay. So now what I'm going to do is I'm going to, these cancels, 3 isn't needed there because these 3 cancel. And so what I have here is a difference of 2 cubes, 2x minus y, 2x cubed minus y cubed. So if I put that into the formula for cubes, I'm going to have a 2x minus y, and then 4x squared minus the 2 of them together, which is 2xy. Oh no, plus. This was minus, therefore this one's plus. And the back one is always plus, so it's y squared. And underneath that, that's where this one goes. 4x squared plus 2xy plus y squared. Ooh, notice that these cancel. So doing the correct cube, taking the 3 out of this, and then being able to do the difference of 2 cubes correctly enables me to cancel that. So my final answer is simply just the 2x minus y. That's all that's left. So being able to factor these allows us to cancel out things. Now, here, there's going to be lots of factoring. But I also noticed that because this is division, we're dividing a fraction. It means we can multiply the fraction, multiply the reciprocal. So back to what we've done with fractions a long time ago and a few times since. And it's that rule that dividing it means multiplying by the reciprocal. Once we've done that, now we need to do some factoring. I'm going to bring that up here, and I'm going to factor each one of the parts. So here we can take an x out, and we have x minus 3. On the bottom, it's a difference of 2 squares, x minus 5 and x plus 5. And because it's times, it's actually like the whole thing is one thing together. The top part of that, x squared plus 4x minus 5, okay, that one can be factored as an, let's see, an x minus an x plus 5 and an x minus 1. Okay. And the bottom one now looks like it's an x minus 3 and x minus 1. Okay, looks like that cancels out. Well, that Yep, that was factored that way. Ooh, let's see. The x minus 3s can cancel out. The x minus 1s cancel out. The x plus 5s cancel out. So what are we left with? Simply an x on top and an x minus 5 on the bottom. All right. That's why the factoring is vital, because you're going to be able to get rid of some things. These two problems show a different type of thing. This is division. So in a way, what it is just like this problem, where it's dividing by something and then we make it multiplying, except it doesn't show it dividing, and then we will forget it. So I'm going to write that here first, because if I wasn't thinking about it, by changing into this, I'll see, oh yeah, I have a fraction and I'm dividing by a fraction, and then my brain will remember that I need to make it multiplying. So it's 3x minus 1 over x times x to the 4th power over 3x plus 8x minus 3. Well, this bottom one, I think we can factor that, and we can if we do it this way. 3, that will be 3x minus 1 and x plus 3. So you can do it with different factoring techniques, but you end up with that. And now I could check it by multiplying here. That this gives me 3x squared. Here I have 9x, take away 1x, there's my 8x, and the back part of it's minus 3. Okay, so what that allows me to do is cancel out this 3x minus 1 and this 3x minus 1, and that x with one of the x's that are there. So what I'm left with is an x cubed on the top, and on the bottom an x plus 3. And that's as far as I'm able to go mathematically with this. The next problem is the same concept, it's just going to be more factoring it. Okay, so now I can see that this would be dividing, but if I make it multiplying, I would multiply times the reciprocal of this, x squared minus 8x plus 16 over 4x plus 5. So now I no longer need that there. I was dividing by that, and now I'm multiplying by the reciprocal. So now what I'm going to do is factor those things. So this top one factors, or this first one now, factors as 4x plus 5 times 4x plus 5. That is actually 4x plus 5 squared. On the bottom one, when I factor that trinomial, I get 3x plus 2 and x minus 4. What I'm multiplying by now, on the bottom I have a 4x plus 5. And on the top of it, that becomes an x minus 4, and it's another x minus 4. This one is actually x minus 4 squared, and this one here is 4x plus 5 squared. Now that we factored it, now we can cancel out some of the things that are the same. Okay, and what I'm left with, from the top, I have a 4x plus 5 and an x minus 4, and on the bottom, the 3x plus 2. And there's nothing more I can do with that. Okay, that's as far as those can be factored or done anything with. So that is our correct answer. So what you've seen here is having to do factoring, using it in this one. This one has just common factors and then a difference of cubes. Oh, and it has a trinomial factor. It has a bunch of them, actually. And here it's dividing by multiplying the reciprocal, and factoring it allows you to cancel lots of things out. And the same thing's true with these. At least some things can be canceled out. Okay. Well, I hope that helps with these concepts. Thank you for watching and listening.